Okay, so here's where we left off yesterday, and we were going to talk about why the A value was 16 before we move on and we do the very, very end of 4.3 today. All right. So I want to figure out what those values are inside the parentheses. I did my substitution already. So I have A times 1/2 plus 1. I'm going to write this as an improper fraction. So that would be 3/2, right? And that's then going to be multiplied by 1/2 times 1/2 minus 2 would be negative 3/2, right? Negative 1.5. And then times 1/2 minus 4, negative 7/2, because that's negative 3.5. So far, so good? Okay. So now I'm going to multiply all of those fractions together. So the denominators, I do 2 times 2 times 2 times 2. I get 16 in my denominator. What do I get when I multiply those numerators together? Positive 63. There we go. I've got this horrible looking fraction that I want to get rid of. I should multiply by what to make it cancel out? 16/63. Multiply by the reciprocal. So that's going to cancel out here, leaving me just an A value. What's going to happen over on the left? The 63 is going to cancel, which leaves me 16. So that's how I got the A value of 16. So from there, and because of time, I'm not going to multiply this guy all the way out, although to put it in standard form, that's what I would need to do. I know that I could take this, and I could put a 16 in here in the place of A. You guys okay with that? Okay. And then from there, it's just multiplying everything out, distributing, combining your like terms together. All right. I want to look at two more things. The first one is very, very similar to this. Same exact idea. We're going to try to write an equation. We'll leave it in factored form for this. But instead of being told my zeros and told f of this x value equals my output, I have a graph. I want you to look at graph A. We'll probably only have time to do graph A, but I'll put the answer for graph B up so you guys can do that one and check your work against mine. What are the zeros on part A? Negative 4. There's a double root at negative 1. So that has a multiplicity of 2 and at 3. So I know when I go to start writing my function, I write f of x equals, what do I need right after the equal sign? Do we know what that is? So how should I represent that here? A. And then I can write my factors based on my zeros. What are my factors going to be? X plus 4. X plus 1 squared. And x minus 3. You guys with me so far? On the previous problems, the ones right back here, they gave me a point. They gave me an x and a y that I could then substitute in to figure out what A was. Do I have information like that here? What do I have? 1 and negative 8. So I'm going to take 1. I'm going to put that in for x. I'm going to take negative 8 and put that in for f of x, my output. So negative 8 is equal to A times 1 plus 4 times 1 plus 1 squared times 1 minus 3. So I've got negative 8 equals a times 5 times 2 squared times negative 2. 5 times 2 squared is 20, right? 20 times negative 2, negative 40. So I have negative 40a over here. What do I still need to do? Divide. I divide both sides by negative 40. Negative divided by a negative means a positive, and then I need to reduce that fraction, 1/5. So here's the a value that I need to use, and now I have enough information to write my final answer. This full polynomial is f of x equals 1/5 times x plus 4 times x plus 1 squared times x minus 3. And now I'm done. It said we were going to leave it in factored form. That's why I'm all done at this point. You guys okay with that?
I have a question.
Yes, sir.
Can you use one of the zeros, like put in like for x, you put in like for the x's and then put in 0 for f of x?
That is a great question. Let's see what happens if we do that. So if I used this right here, input of 3, output of 0, right? I'd put a 0 in right here. I'd get a 7 here, 4 squared, that would give me 16. What would happen here?
You get 0.
I get 0. And we're multiplying all of this, right? What happens if I multiply things by 0?
Everything becomes 0.
Yeah, so I would end up with 0 equals 0, which is true, but it's not helpful to find my a value.
Wouldn't it be undefined because it'd be 0a and you'd have to define both sides by 0?
Good question. Would it be 0a? I mean, it would be 0a, but what is a times 0?
0.
That would simplify further to 0. So I wouldn't actually have to divide both sides. That is a great thought, though. All right. Do you guys have any other questions for me about this? All right. I will put up in Canvas this full correct standard form polynomial so you guys can check your work against mine now that we know how we got the a value. And I will have the factored form with the correct a value for part B so you guys can look at that, practice, and check your work against mine. There is one last big idea that we need to cover in section 4.3, and it's called Descartes' rule of signs. It's how we can determine how many positive real zeros we have, how many negative real zeros we have, and how many non-real zeros we have. If you guys want to snap a picture of this, that's fine. It is in your book. It's also up on Canvas.
You have a book?
You do have a book.
Oh, yeah.
I don't expect you guys to cart it back and forth all the time, but it is a really helpful resource, especially if you need extra examples of something. There's often worked out problems with steps and explanations. All right. So the first part of Descartes' rule of signs, and we'll practice this in just a minute, says that I can determine how many positive real zeros there are by counting the number of times the sign changes in f of x. So if it goes from being a positive number and then, say, minus 4x, that's a sign change. And then it goes back to being a positive, that's another sign change. I'm going to count how many times the sign changes. Whatever I come up with, that's the maximum number of positive real zeros we could have. Or it could be less than that by a number that is an even integer. So let's pretend that the sign changed 5 times. I counted it up, sign changed 5 times. There could be 5 positive zeros, or 3, or 1? What about if I counted it up and there were 6 sign changes? Could be 6 or 4 or 2 or none. So we're going to count up how many times the sign changes. We're going to write that number down. And then we're going to minus 2 from that if we can. And we'll do that until it would end up with a negative number, because we can't have a negative number of positive roots. To figure out the number of negative real zeros, we're going to sub in negative x. And after we simplify that, we're going to count the sign changes again. I want to look at some examples because this is all just a lot of mishmash of words right here. It's much more concrete if we do it with examples. Okay? Okay. Example A over here. Here's my function f of x. Let's count how many times our sign is changing. 4x cubed, is that positive or negative? Positive. So when I look between these two, did the sign change? Yes. It went from being a positive to being a negative. There's a minus right there. So that's one sign change. I have a negative 6x squared, and then it goes to being positive. Is that a sign change? So that's 2. Positive x minus 3, sign change. So there is a max of 3 positive roots. So I'm going to write this down right here. Positive roots, there could be 3, or it can be smaller than that. Could it be 2? No. Because I can take away from this, I can make it smaller, but I always have to be minusing an even number. Because remember, my non-real roots always come in pairs. So it could be 3, or if I take away 2 from that, what would I get? 1. Could be 3, or it could be 1.
So why can't it be 2?
Why can't it be 2? Because I take my maximum, and I have to only subtract even numbers from that. So if my maximum is 3, even numbers, 0, 2, 4, if I just take away 1, is that an even number? No, 1 is not an even number, so I can't minus 1 from it. The smallest thing that I can minus from it is 2 to end up with a change. You're always going to minus 2.
Wait, why?
I'll show you in just a minute. It'll make more sense when I get the rest of this table built, I promise. Okay? Let's go figure out our negatives. I'm going to take the function f of x, and I'm going to substitute negative x in. So 4, and then this would be negative x cubed minus 6 times negative x squared plus negative x minus 3. Negative x cubed, is that going to be a positive or a negative? Negative. So I have negative 4x cubed. What about negative x squared? That'll be positive, so that minus 6 isn't going to change. What's going to happen to the next spot? Plus negative x. It's going to be negative, so minus, and then minus 3. So far, so good? Pedro, do you have a question? Okay. Let's count how many times the sign changes. Did the sign change here? Nope. Negative, negative. Did the sign change here? Nope. What about here? Sign didn't change at all. No sign changes. So there are No negative roots.
I don't get it.
Do you see the negative 4x cubed?
Yeah.
And then it's a negative 6x squared?
Oh, okay, I get it.
You got it?
Yeah.
Okay. No, I'm not comparing it to the first one at all. I'm just looking to see, do we go from a minus sign to a plus sign? All right, so there are absolutely no negative roots possible. Non-real.
Isn't 6x supposed to be positive?
Well, this would become positive, but what happens if you take x squared and multiply it by negative 6?
Okay.
It's going to stay negative. Good question, though. When I add up all of my roots, it has to equal what about the equation? Has to equal my degree. What is the degree here? 3. 3 plus 0 plus what would give me 3? 0. So it's possible there's 3 real roots, no negative roots. Sorry, 3 real positive roots, no negative roots, no imaginary roots.
Where did you get the other 3 from?
Where did I get what other 3 from?
Look at the 3 on the right.
That?
Yeah.
That's the degree of my polynomial. These numbers above it have to add up to the degree of my polynomial.
Oh, I thought you were just adding like that.
Oh, not yet.
Okay.
I just know what it has to be equal to.
So do you need to put the other 3 in?
Well, 1 plus 0 plus what?
2.
Give me 3. 2. There are only 2 possibilities here. There's either 3 positive roots, and that's it, so 3 x-intercepts, or it has 1 x-intercept and 2 imaginary roots. Let's try another one. I know we're short on time, but let's do another example so that we have something else to look at. How many times does my sign change here? Does it change here? All right. Does it change here? Does it change here? No. Positive to positive, no change. What about here? Yes. So that's 3. Does it change here? No. So there's a maximum of 3 positive real roots. What's the other possibility? If it's not 3, it could also be 1. Now we're going to sub in negative x. I realize the bell is probably going to ring while I'm doing this. Oh, that should be to the 7th power there, not squared. If you guys want to hang on just a minute, we'll talk about these. I don't know how far you have to walk, but I am willing to write passes. I got to scoot this guy over. All right. So I would have negative 3x to the 7th minus 4x to the 4th, minus 3x cubed plus 2x squared plus x minus 3. How many times does our sign change?
2.
Yeah. Doesn't change until here, but then it changes again here. So 2 is the maximum there for negatives. What is our degree, though?
7.
7. So non-real roots. How many would there have to be, even if there's 3 positive and 2 negative? 2. Because it has to add up to 7. could have 3 positive roots, and for negative roots, does it have to be 2? It could also be 0, because I can subtract 2 from that. If it has 3 positives and no negatives, how many non-reals would it have to have? 4. If there's 1 positive and 2 negatives, how many non-reals? 4. What about if there was 1 positive and no negatives? 6. Degree of 7. So there are 4 different possibilities here. Those are all the possible combinations for zeros. Homework for 4-3 is due on Monday. It's due Monday night, so if you guys have questions after working on it over the weekend, please come and ask me or send me messages, all right? I will post the answer for part C on Canvas as well.
Can I get a pass?
Absolutely. Have a great weekend, everyone.